Good everyone, my name is Graphics. If you look at the front of your screen, you will see a circuit that has seven elements, right? Which five of them are passive and two of them are active. The passive element are the resistors there, which have resistance of 7 ohms, 5 ohms, 3 ohms, 4 ohms, and 4 ohms again. And the active element are the voltage source, which have 30 volts and 12 volts respectively. Now we are told to find this current in this mesh, right? We're looking for the mesh current and also the branch current, and we have five of these currents. I signify our current. So we have I1, I2, I3, I4, and what? I5 respectively. Now we are to use the nodal analysis or the node voltage method in order to detect this current that is moving around this circuit. Now, the first thing I will do to enhance our understanding is for me to just label each point on this circuit. So I'll call it to be my point A, point B, point C, point D, point E, point F, G, and H respectively. All right. For you to use your nodal analysis or the node voltage method is for you to detect the node that has three currents coming in or going out or three branches attached to it. And what is a node? We know a node is a point where two or more currents meet or branches meet, right? Now, but in this case, the current at that point must be at least what? Three. Must be three. So if you look at this closely, the point that is guilty of this accusation is point B and point C. So I'll call it node B and what? Node C. These are the 2 points that is guilty of that accusation. So the first thing you do, you will considering each node because the node analysis makes use of what? The KCL, the Kirchhoff current law that says that the algebraic sum of current entering or leaving a node is equals to what? Zero. Now I'm going to consider, to save our time, I will consider node B. Now you consider node B, if you look closely, the current, I'll put my equal sign here, right? So the left hand side will be the current coming in and the right hand side will be the current going out. Let's take it that way. It can be any way. So let's see. We are focusing on this point node B. Now I1 is going to B, right? Look at the way it is moving to B, means it is entering. So I'll put it at my left hand side of the equal sign because it's what? It is entering. Look at I2 is leaving. You can see where my arrow is moving. It's moving away from that node B. So we'll put it at the right hand side because it is what? It is leaving. Then I3 is also leaving. You can see where the arrow is moving away from node B, right? So we say that we'll put it at our right hand side, adding both of them. So you add the one that is leaving together and you also add the one that is entering. So they are two separating. So taking, remember, we're taking point B as our reference point. So we'll now have what? I1 is equals to what? I2 plus I3. Is that okay? I will term that my equation. I can easily term that to be my equation 1. Is that okay? Now, if we now move forward, we want to look for I1. To look for I1, what you're going to do, it will be the voltage from where I1 is coming from. Look at I1 is coming from the 30 volts. Meaning that 30 volts is the higher voltage because current moves from a higher potential to what? To a lower potential. So the voltage from where the current is coming from minus the voltage to where the current is going to. So if I take this point here, I'll call it my V1, meaning that the current is going to V1. You can make it want to be VB or anything. So the 30 minus V1 divided by the resistance in between those two voltages, right? And that is what? 7. So my I1 is 30 minus V1 all over 7. I will term that my equation 2. Similarly, to get I2, I2 is in between the V1 and the reference point, which is the earth here, right? So at that point, anything at this baseline here is time to be what? 0. Is that okay now? So it will be the voltage from where the current is coming from. The current is coming from V1, right? That is at node B. It's coming from what? V1. To where the voltage is going to, there's nothing there. So we'll say what? 0, right? All over the resistance in between both of them, which is 5. So I'm having my I2 to be equal to what? V1 minus 0 over 5, which means I'm saying V1 over 5. Hope I'm communicating. So I'll term that equation 3. Now we'll go to I3 now. I3 is in between V1 and what? And V2. Let me term this point C here as what? My V2. So node C, I will term it as my what? My V2. So my I3 will be the voltage from where the I3 is coming from, which is V1, to the voltage minus the voltage to where the I3 is going to, that is what? V2, all over the resistance in between two of them, which is what? 3. So we say my I3 is equals to what? V1 minus V2 over 3. That will be my equation 4. Is that okay? Now, we will now substitute I1, I2, and I3 into equation 1 above. Now, if you look at my equation 1, the first one here is I1. So what is my I1? My I1 is 30 minus V1 over 7 equals to, what is my I2? My I2 is what? V1 all over 5. And my I3 is given as what? V1 minus V2 over 3. Is that taken? So you can easily look for the LCM and expand and get an equation. But you can easily make a lot of mistakes if you go through that process with experience. So I will advise you to do it the way I'm about to do it. It will give you a faster and more and less confusing approach, right? So let us see. Now, if you look at that very well, if you look at that aspect very well here, what you are going to do is this. If you look at 30 minus V1 over 7, it's the same thing as saying 30 over 7 minus V1 over 7. Is that okay? Because they have the same denominator. Now, close to V1, we have a silent 1 close to V1. Don't forget that. So we'll now say that 30 divided by 7, right? That will give us 4.29. I'll write it down here. Is that taken? Minus the quotient of V1 there, which is 1, divided by what? 7. That will give me 0.14 V1 equals to, if you look at the same thing is applied here, the quotient of V1 here is what? 1. So 1 divided by 5 will give us what? 0.2 V1. Plus, if you look at the other one also, quotient of V1 here is also given as 1. So we'll say that 1 divided by 3 is given as what? Given as 0.33 V1. Is that taken? Minus, quotient of V2 here is 1. So 1 divided by 3 again, given as what? 0.33 V2, because it's V2 that is there. So this is what we have, the equation that we have here. So if you simplify further, I will take this negative 0.14 V1 to the right hand side because I'm collecting like terms. So I'll be having 4.29 is equals to, in the right hand side I have 0.2 V1 plus 0.33 V1, then if this minus 0.14 V1 comes to this side, become what? Plus 0.14 V1. Then we have minus 0.33 V2. Now if you add, what you now have now will now be V 4.29 is equals to, when you sum 0.2 V1 plus 0.33 V1 plus 0.14 V1, you'll be having 0.67 V1, then minus 0.33 V2. You cannot add them together because they have different variable. They are not like terms. We have V1 and V2. So I will term that my equation 5. Is that okay? Now, we'll go to the next one again. We'll move forward to what? To the next one. We are going to consider node what? Node C. We are done with node B. We'll now consider node C. So at node C, we have 3 current that's attached to that particular node also, which is I3, I5, and what? I4. Is that taken now? So now what do you notice? I3 and I5 is coming in. Look at my arrow moving towards point C. So both of them are going in. So you take them, you add both of them. So I told you the one entering will be at my left hand side and the one leaving should be at my right hand side. So I put my equal sign. So the one entering is given as what? Is given as I3 plus I5 because they are both entering. Is that again? Equals to the one leaving. The one leaving is what? My I4. Look at it is moving away from the node C. Can you see that? So it's leaving. So equals to what? My I4. It can be vice versa. It can be the one leaving equals to the one entering, or the one entering equals to the one leaving. So we are all saying the same thing. Now I'll term that my equation 6. Now in moving further, I will now say, okay, my I4. So my I4 here is in between, is in the part of what? C and F, right? So it will be the voltage from where I4 is coming from, which is V2, you can see that, minus the voltage to where I4 is going to. There's no voltage, so that is 0, right? So it will be all over the resistance in between the two of them, yes, which is 4, right? V2 minus 0 all over 4 will be having V2 over 4. So I will term that my equation 7. So for the I3, look at the I3 closely. The voltage from where I3 is coming from, look at the I3 moving, is V1 minus the voltage to where I3 is going to, which is what? V2, all over the resistance in between them, which is what? 3 ohms. So my I3 is what? V1 minus V2 over 3. And I'll call it my equation 8. For I5, it will be the voltage from where I5 is coming from, look at it's coming from 12, right? Minus the voltage to where I5 is going to, which is what? V2, all over the resistance in between both of them, which is what? 4. I'll term that my equation 9. Is that okay? So I'm only putting equation so that I can easily locate them in order to enhance our understanding. Substitute into equation 6 above, right? We'll say that my I4 will now be 4 V2 over 4 equals to my I3, which is V1 minus V2 all over 3, plus my I5, which is what? 12 minus V2 all over 4. Now, I will apply the same thing here. The coefficient of V2 here is 1. So 1 divided by 4 is 0.25 V2 equals to coefficient of V1 here is 1. 1 divided by 3 is 0.33 V1. And the coefficient of V2 here also is 1. 1 divided by 3 will give me 0.33 V2. Remember there's minus in between. Then plus, if you divide 12 over 4 here, we'll be having what? 3 minus the coefficient of V2 here is 1. 1 divided by the 4, we have 0.25 V2. Now if you collect like terms, we will now be left with 0.25 V2 equals to 0.33 V1 minus 0.58 V2 plus 3. Is that taken? It is just collecting like terms, right? Bring all the V2s together and all the V1 together, and you separate the constant. That's why I just did here. So at the end of the day, you'll be having this, because when you take your plus 3 from the right hand side to the left hand side, become negative 3. And when you take your 0.25 V2, which is positive at the left hand side, if you take it to the right hand side, become what? Negative 0.25 V2. So that's what I just did here. So now collect like terms, right? So collecting like terms here now, we now have minus 3 that taken is equals to 0.33 V1, right? Minus 0.83 V2, because when you bring 0.25 V2 and 0.58 V2 together, both of them have negative, you'll be having negative 0.83 V2. So I'm going to term that my equation 10. So taking now. Now, we'll now combine equation 5 and 10 together, solve it simultaneously. So this is my equation 5 and 10, that is 4.29 equals to 0.67 V1 minus 0.33 V2, that is my equation 5, and minus 3 is equals to 0.33 V1 minus 0.83 V2, that is my equation 10. So what I will do is, using the elimination method, I want to make the coefficients of V1 in both equation 1 and 2 to be the same. So what will I do? I'm going to take the coefficient of V1 in equation 10 and multiply that everything in equation 5, and I will take coefficient of V1 in equation 5 and multiply everything in equation 10. So that's why I'm putting multiply by 0.33 here and multiply by 0.67 here. So if I should do that, this is what my equation will now look like. If I should multiply 0.33 times 4.29, I will have 1.42 equals to, if I multiply 0.33 times 0.67 V1, I will have 0.22 V1 minus, if I multiply 0.33 V2 times 0.33, will give me what? 0.11 V2. That is my equation 11. I will come again. I will multiply 0.67 times minus 3, I will have minus 2.01 equals to, if I multiply 0.67 times 0.33, I will have 0.22 V1 minus, if I multiply 0.83 V2 times 0.67 will give me what? 0.56 V2. That will be my equation 12. Now what do you notice? The question of V1 and in both equations is not the same, which is 0.22, 0.22. Now since both of them are positive, I will now subtract them because both of them are positive. So if yours is negative, you are going to add them. But since both of them are positive, I will subtract them. So in subtracting, meaning that I'll use negative sign to multiply everything in equation 12. Is that taken now? That I mean by subtracting. So if I multiply minus times minus 2.01, I will have plus 2.01. Minus times 0.22 V1 will give you minus 0.22 V1. Minus times minus 0.56 V2 will give you what? Plus 0.56 V2. And that will be still my equation what? Equation 12. Now because I'm actually subtracting them. So if you do the needful now, you discover that 1.42 plus 2.01 will give us 3.43. 0.22 V1, right, minus 0.22 V1 will give us what? 0. Now minus 0.11 V2, right, plus 0.56 minus 0.11 V2 plus 0.56 V2 will give us what? Plus 0.45 V2. So if you make V2 the solid of the formula, my V2 will be equals to what? 3.43 divided by 0.45, and that is what? 7.62 volts. Is that taken? Now I'm going to now substitute V2 equals to 7.62 volts into equation what? Equation 5. So my equation 5 is telling me 4.29 equals to 0.67 V1 minus 0.33 V2. So when I input my value, so I'll be having 4.29 equals to 0.67 V1 minus 0.33. Instead of me writing V2, I'll now put the value of V2, which is 7.62. So my 4.29 will now be equals to 0.67 V1 minus 0.33 times 7.62 give you 2.52. So collecting like terms, taking my negative 2.52 to the left-hand side of the equal sign, I'll be having 4.29 plus 2.52 because it turned to positive equals to 0.67 V1. Now when you add 4.29 plus 2.52, you'll be having 6.81, right? Equals to 0.67 V1. So dividing both sides by 0.67 V1, my V1 will now be equals to 6.81 divided by 0.67. So my V1 will now give me 10.16 volts. So I've gotten value of V1. I've also gotten the value of V2. Now it's for me to now have my value for, I'll now substitute them into equation 2, 3, 4, right? 7, 8, and 9, which are what we have here. Is that taken? So let's start inputting our value for V2. So if you input to get your value of V1, now I want to get our value for the branch current now and the mesh current. So to get our I1, right, from the equation 2, we know I1 is equals to what? 30 minus V1 over 7. Is that taken? So the value of V1 is given as what? The value of V1 is given to be 10.16. Is that taken? So my I1 will now be equal to 30 minus 10.16 divided by 7. So 30 minus 10.16 will give me 19.84. Divided by 7, my I1 is what? 2.83 ampere, or you can say 2.84. Now substitute your V1 equals to 10.16 into equation 3 also. My equation 3 is telling me I2 is equals to V1 over 5. And my V1 is 10.16 divided by 5, you'll be having 2.03 ampere. Now also substitute V1 into equation V1 equals to 10.16 and V2 equals to 7.62 into equation 4. So my I3 will now be giving me V1 minus V2 all over 3. So when you put your value, you'll be having 10.16 minus 7.62 divided by 3. We're going to be having 2.54 divided by 3, which will now give us 0.85 ampere. Is that again? So we move forward. You also substitute your value of V2 equals to 7.62 into equation 7. So we know that my I4 is in equation 7, and that's given as what? V2 over 4. And V2 is 7.62 divided by 4. That will give us what? 1.91 ampere approximately, right? So you will now substitute also V2, which is given as 7.62 into equation 8. I don't have to waste my time with that because it's the same value as equation 4. I will know what equation 4 is as we've checked, right? The same value. So we have the same value. Now now substitute our V2 into equation 9. So equation 9 is for looking for I5. So my I5 will now be giving me as 12 minus V2 over 4. And we know V2 is what? 7.62. So 12 minus 7.62 all over 4 is equals to what? 4.38 all over 4. So that will now give me 1.09 ampere. So my I5 is what? 1.09 ampere. So if you have found this video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.